Hi, I'm Rich with InsideHPC. We're here at SC19 in Denver, Colorado, and today we're at the TYAN booth with Phil Marr. How you doing, sir?
I'm doing good. We're here back in Denver again. This is our third time in 5 years, I think.
Yeah, it feels good, but why don't we start at the beginning? What's new with TYAN here at SC19?
Yeah, we're here at SC19. Here back again. We've got a number of Intel platforms here on display. We're standing right here next to a new GPU server platform we got. I don't know how many people have heard the keynotes this show, but one of the big things that's been talked about is how much storage is exploding into the HPC field. We're making more data than we know what to do with. So one of the problems is where do we store it and how do we get into the systems. So we have taken a GPU server that we've had before. This is a 4U platform with up to 10 GPU support, and we have changed the front of the server to accommodate large form factor drives. So I'm going to have two options to this. This is the full configuration, but I can do either 12 3.5-inch drives or I can do 24 3.5-inch drives. If you're using hot GPUs like a big 300 watts V100 and you're using 10 of those, we'll ship this to you with 12 drives and the top half is open for venting so you can get the airflow. However, something that's interesting is for video analytics workloads, you have a very large data set you're trying to work with. So that kind of application, we're looking at using 10 or even 20 Tesla T4s on this platform, and you can load it up with up to 24 hard drives. And you can mix and match up to 4 NVMe in there as well.
So how much data are we talking on board here? So you have to do the math?
On the spot here. I'm just going to use 10 terabytes as an easy thing here. So if we're talking 10 terabyte drives, I got 24 of them. That's 240 terabytes, right? And it only goes up from there. So
Phil, what do we got here?
So this one here is a database server, a distributed database, a Hadoop platform. It's very good at running the current distributed database platforms. A lot of the white papers out now for Hadoop suggest a 3-to-1 hard drive to NVMe ratio. So I've got 12 3.5-inch hard drives here, and I've got 4 U.2 NVMe bays. And the party trick this thing has is I've got a hard drive tray, a drawer that pulls out. So on previous iterations of this kind of platform, you'd have to take the whole server outside of the rack. And that's a mess with cables, cable management, things like that. You just don't want to do it. So with this, you've got a pair of levers right here, and this slides out, and I've got 12 3.5-inch drive bays. So I don't have to worry about pulling the chassis out of the rack. It's just there, and it's easy to get to. And these drive trays are also toolless. This is an engineering prototype. These have screw holes, but the one that we're shipping, it is toolless. So it's toolless for 3.5-inch drive trays. You slap it in there, and we've got yourself 12 hard drives in an easy to maintain package. And one of the things that's important for these kind of workloads is you want a high core count ratio, and it's typically lower cost to go with 2 mid-range core count processors than 1 really high core count CPU. So this is designed to tackle that workload. We'll have 2 options with this one. People like to use low-cost SATA hard drives to bring the cost of the platform down. So I have an optional SAS controller on this. You don't need to use it, but it is there if you need it. One last thing that I really like about this is people tend to be upset when the chassis gets much bigger than 35 inches deep. You have to get into a bigger rack. You're talking 1.2 meter territory. So we kept the chassis short. This thing is about 35 inches deep. And so that way we maintain outstanding rack compatibility. So.
Well, Phil, it's great to see all this innovation with Intel's processors here at TYAN, and I hope you have a great show this week.
Thank you very much. Good to see you again.